All right, this is our Trig Unit 2, Topic 1, new topic on radian measure. All right, and this is a really good topic to start with, and it's a pretty important one that's going to be very meaningful as we move throughout this entire unit. Now, until now, we have used degrees to measure angles, but what exactly is a degree? I mean, if you think about it, a degree, 1 degree, is equal to 1/360th of a circle. Of a complete circle, okay? And that's kind of confusing to understand. I mean, who established what 1 degree is, and who established that there's 360 degrees within a circle? So it's just kind of a weird way of measuring angles. So we want to come up with a better way of measuring angles, and we measure an angle based on its arc length and its radius. So what I mean by that is if we have an angle, right? Okay, well let's think about our circle here, okay? Our circle. If we measure an angle, so think about this angle right here that goes like this, okay? The arc that it creates, we call it its intercepted arc. So the arc starts right here, like all angles start right here, and this is where it ends. So this right here, I'll use a different color to show it. This right here is its arc length. The arc length is the actual distance of the arc, or the part of the circle it's created. And we want to measure theta not based on degrees, but we want to measure it based on this arc length. So the idea is that we measure angles in terms of the arc length, and we call S the arc length, and we also measure it based on its radius. Now remember, the radius is this distance, but it's also this distance right here. So if you think about this piece of pie, if it was like a pizza, and this little chunk or slice of the pie would have lengths of r on each side, that would be the radius, and then the crust here would be the arc length, the S, and we want to measure theta based on that. And the actual way that we do this is we call this way of measuring angles, we call this radians, okay? And it's abbreviated RAD, okay? So basically a radian, theta in radians, is equal to the arc length divided by the radius. So that's a pretty important formula to understand right there. So this is when theta is not in degrees, but theta is measured in radians. So the idea behind this and why this is important is that it makes more sense, to be honest. Now you're going to say, well, no, this is more confusing, but it makes more sense to measure an angle based on its arc length and its radius. Now this should make sense. Smaller circle, smaller radius, smaller arc length. Larger circle, larger radius, larger arc length, but the same angle. So it's all, because we're dividing it, we're looking at the proportion of the arc length to the radius. So let me kind of make that point real clear here. So we get a small circle, medium-sized circle, really, really, really big circle. I guess they're not all that much bigger. But anyway, here's the idea. If we create this angle right here, okay, the same angle, this is the angle theta, and it's the same for every circle, no matter the size of the circle. But notice that the small circle, the arc length is smaller. Medium, it's this length, and obviously bigger circles, bigger arc length. But as the arc length gets bigger, so does the radius. Here the radius was small, then here, and then here. So no matter the size of the arc length or the radius, that's why the measure of theta is the arc length divided by the radius. So this angle right here, theta, is the same whether you have a small circle, medium circle, big circle. It's because it's the proportion of the arc length divided by the radius. So obviously both of those are increasing or decreasing based on your circle. So that's the idea of radians, and it makes a lot more sense than this degrees, because degrees, it's kind of like an arbitrary thing. I mean, somebody just invented that 1 degree was, who invented that there was 360 degrees in a circle? Why not 359 or 361? I mean, who knows? But when we base it on radians, it makes so much more sense to base it on its arc length divided by its radius. So let's try to understand exactly what 1 radian is. Okay, now think about this right here. Here's an example, and this actually shows you what 1 radian is. Okay, so now remember, again, radians of a circle is based on the arc length divided by the radius. So think about this. When your arc length S is equal to the radius, when the arc length and the radius are the same length, you get S, which would be the same as R. So basically R divided by R would be 1. That's when you would get 1 radian. So 1 radian occurs when your radius, this red distance right here, is the same as the arc length. So if I would actually take a piece of string you know, and lay it out. Lay that piece of string out from the center all the way here. So I'm going to take this piece of string, and then I'm going to take that piece of string and slowly lay it out across the arc, or the actual part of the circle, the arc of the circle. And then when that string ends right here, that's when 1 radian is created. So here is 1 radian. 1 radian right there. So 1 radian is best described when the arc length equals the radius. Because remember, this is our formula right here for radians. Arc length divided by radius. So this is a really important formula. I can't stress it enough. But for this formula to work, theta is not measured in degrees, it's measured in radians. So 1 radian is when the arc length equals the radius. So the next thing we'll talk about is, well, how many radians are in a full circle? Because everybody knows there's 360 degrees in a full circle. Well, this picture here shows us how many radians there are in a circle. So here's 1 radian right here. Again, this is when this distance right here, the radius, is equal to that arc length. So think if I took that piece of string, the radius, and I laid it out, and then I laid it out again, and then I laid it out again, and then I laid it out again, and then again, and then again. I would, and no matter the size of the circle, I would get 6 full radians in a circle, and then this little bit extra. 6 full radians are going to be in a circle. 6 full radians. All right, so hopefully that makes a lot of sense. And you say, well, what if the circle's bigger? Is there going to be more than 6? No. It's the same thing with degrees. It doesn't matter the size of the circle. There's 360 degrees in it no matter what. Same thing with radians. And that's because if you make a bigger circle, then your radius is going to be bigger. Right? So when you lay that string out, it's going to, again, take 6 strings plus a little bit more. If you make it smaller, then the radius is going to be smaller. So it's still going to take 6 of those smaller radiuses and a little bit extra to go all the way around. So if we think about it, it's the arc length, remember, arc length divided by the radius. Now, how, and so hopefully this makes sense, this 6 and a little bit more. So let's try to think about this more mathematically. The arc length of an entire circle is known as the circumference. The circumference. The circumference is the arc length of an entire circle, and you guys should know from geometry that is 2 pi times your radius. Again, bigger radius, bigger circumference. Smaller radius, smaller circumference. So if we think of how many total radians are there in a full circle, well, I would take the full arc length of an entire circle, that's S, would be 2 pi r, divided by r. Now, notice the r's are going to cancel, so it actually doesn't matter what r is measured in. R could be 5 inches or 5 miles or 7 miles or 7 centimeters, whatever those numbers are, it's going to go here and here, hence it's going to cancel out, and you get there are 2 pi radians in one full circle, regardless of the radius. 2 pi radians. Now, actually, technically, if you think about what unit are radians measured in, there's actually no units. We call them radians, but circumference is measured in distance, say inches, and radius would be measured in the same thing. So technically, the units would cancel. So that's why we just call them radians. It's a concept. Now, if you use your calculator and you type in 2 pi is approximately 6.28, right? Approximately. So now you should totally understand that there are 6 and a little bit extra radians in a full circle. So 6 radians, and then the point to it represents the little bit extra that are in a full circle. But the exact value would be 2 pi. So there's 2 pi radians in a full circle. So hopefully that idea makes a lot of sense to you guys. Okay. So now let's kind of expand on that a little bit here. Let's kind of thinking, okay, well, 0 degrees is zero revolutions around a circle. I mean, if you've gone 0 degrees, you haven't even gone around a circle. So that would obviously be 0 radians. Okay? So now 90 degrees. 90 degrees is 1/4 of a revolution around a circle. It's a quarter of a revolution. So you got to come to the side and do a little bit of dirty work. A full circle is 2 pi radians. We're talking about 1/4 of a circle, 90 degrees. So 1/4 of that would be 2 pi times 1/4. That would reduce to pi over 2. So there's pi over 2 radians is the same as 90 degrees. How about 180 degrees? 180 degrees is a half a revolution around a circle. Well, a full circle has 2 pi radians. Half of that would be, the 2's would cancel, and you'd get pi radians. So half a circle is about 3.14 radians. 270 degrees is 3/4 revolutions. It's 3/4 the way around a circle. So let's see here. So one circle, as a full circle, is 2 pi radians times 3/4 would be, let's say the 2 would reduce with that 4, so it'd be 3 pi over 2 radians. Okay, and 360 degrees, one full revolution around a circle would be, well, 2 pi times 1. We already know that, 2 pi radians. Okay, so based on this idea of thinking about how many revolutions is that degree, then you can convert that to radians. So let's do 60 degrees. So how much of a circle, what fraction of a circle is 60 degrees? Well, by the way, if you weren't, I mean, obviously 90, 180, 270, 360 are easy, but think where I got that from. 90 degrees out of 360. 90 divided by 360 is 1/4. 180 divided by 360 is 1/2. 270 divided by 360 is 3/4. 360 divided by 360 is 1. So 60 degrees would be 60 out of 360, and that would reduce to 60 out of 360 would reduce to 1/6 of a circle. So that would be 2 pi's, a full circle, times 1/6 of it would be pi over 3 radians. So 60 degrees would be pi over 3 radians. We could do this with 45 degrees as well. 45 degrees is how much of a circle? Well, it's 45 out of 360. That's the fraction, right? And 45 out of 360 is 1/8 of a circle. 1/8 of a circle. So I got to think 2 pi is a full circle. I need 1/8 of that. So that would be pi over 4 radians. And we can honestly continue this on and on forever. I mean, we can just keep doing more examples. Let's do a couple more here. Just try to get it somewhat familiar with it. Let's do kind of a weird angle, right? Like 80 degrees. I mean weird in the sense it's not one of our perfect angles from the unit circle. Well, 80 degrees divided by 360. So 80 degrees is 2/9 of a circle. I'm just reducing that fraction, so it's 2/9 of a circle. So 2/9 revolutions. So 2 pi times that 2/9 would be, let's see here, 4/9 of a circle. So 4 pi over 9 radians. Okay, so that is how many radians are in that. All right, we can even do something like really weird, like 347 degrees. Well, that's 347 out of 360. So that's the fraction that 347 is, and I don't believe that can be reduced. Yeah, I mean it can't be reduced at all. It's kind of a weird number. So in terms of radians, that would be 347 out of 360 times 2 pi. I know I've been putting the 2 pi in the front, but I guess it doesn't matter. It's multiplication. So let's see. The 2 is going to reduce that to a 180. So it'd be 347 out of 180 pi radians. Okay, a weird answer, but that is how many radians 347 degrees would be. So the process is fairly simple. Let's just do one more. I just want this process to be really easy. So 150 degrees. 150 degrees is how much of a circle? So 150 divided by 360 is 5/12 of a circle. So 150 degrees is 5/12 of a circle. So in terms of radians, that would be 2 pi times the 5/12. And let's see, the 2 reduces that 12 to a 6. So it'd be 5 pi over 6 radians. So hopefully this idea of radians makes sense to you. It's all what part of a circle it is. What fraction of the circle. And the key conversion we need to know is, like conversion factors. Like everybody knows that, 1 foot is 12 inches or 1 mile is 5,280 feet. Those are conversion factors. So our conversion factor, the main one is right here. 1 revolution is 360 degrees or 2 pi radians, but this one's actually used a little bit more only because it's reduced. 180 degrees is pi radians. It's just reduced more basically, but it doesn't matter which one you'd use. But that's the key conversion idea, is the understanding that a full circle has 2 pi radians. So what part of a circle are we talking? Times it by 2 pi to figure that out. So hopefully that whole process there made a lot of sense to you. All right. Now, let's see here. I had another slide somewhere here. Okay, here we go. Okay, so here's kind of a picture of this. I want you guys to be able to see this picture here. This picture represents what's on your unit circle. Okay, so we got 0 degrees or 360. Remember, it's the same thing because it's going all the way around here. That represents 2 pi radians. So right here, 90 degrees, right? 90 degrees or 1/4 of a circle would be 1/4 of the 2 pi or pi over 2. 180 degrees is half a circle or half of 2 pi radians. That would be pi radians. And then 270 degrees is 3/4 of a circle or 3 pi over 2 radians. Now notice that we don't put the RAD on here because technically you don't have to. Technically there's no units for radians. So if you don't have any units after it, it's implied that it's radians. But usually I like to write the RAD for radians. But technically you don't have to. So if you just say pi over 2, it's implied that's in radians. Here's some more. Here's the 45 degrees, right? 45 degrees is 1/8 of a circle, or 45 3/60ths, 1/8. And 1/8 of 2 pi is the pi over 4. So you can, the reason why I'm showing you this is you can actually count by 1/4. So here's 1/4, 2/4, 2/4 is 1/2, 3/4, 4/4 is pi, right? 4/4 would be 1, so 1 pi. 5/4 pi. 6/4 and 6/4 would reduce to 3/2. 7/4, 8/4. So breaking up a circle in 2/4 is something that's very, very common to do because it force 360 goes, 4 goes into 360 evenly. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 8/4, 8/4, 2 pi. Right? That's where the 8/4, 2 pi comes from. We could also break it up this way here. So remember, breaking it up by 30 degrees, right? So think about this. 30 degrees. Sometimes you got to sit back and think for a second. 30 degrees is how much of a circle? Well, 30 degrees is 1/12 of a circle. So that'd be 1/12. 30 degrees is 1/12. So how many radians would that be? Will be 1/12 of a full circle of 2 pi radians, or pi over 6. So 30 degrees is pi over 6 radians. So I can count by 6, 1/6 pi. So this is 1/6 pi, 2/6 pi, 2/6 we reduce to pi over 3. So 1/6, 2/6, 3/6, 3/6 right here, right? 3/6 would be 1/2 pi. 1/6, 2/6, 3/6, 4/6. 4/6 would reduce to 2/3 pi. The 150 would be 5/6 pi. And then 180 would be 6/6, which would be 1 pi. Just 1, right? 6/6 would be 1. So we got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. 7/6 would be 210 degrees. 8/6, which would reduce to 4/3. And then 9/6, 9/6 we reduce to 3/2, and we should already know that. So let's again, I always lose track and need to go back and count. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 5/3. 11/6. Sometimes I reduce, sometimes I don't. And then finally, 12/6 would be a full all the way around a circle, counting by 6. 12/6 would be 2 pi. 12/6, 2, right? So again, we can count by fourths, like we saw in the previous example. This one's counting by sixes. And notice I'm doing 45 degrees, 30 degrees, and 60 degrees. Those are our special angles that we should know. Those are our famous angles, right? So we got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. I can continue and go 13/6, but 13/6 would be the same thing as pi over 6. So anyway, the idea is that I like counting by fourths and I like counting by sixths because those are my main 3 angles, 45, 30, and 60. All right. So here's another nice picture of all that in case you want to copy your notes. Much nicer than looking at the one that I just made up. 1/6, 2/6, that's 1/3. 3/6, 1/2. 4/6, 2/3. 5/6, 6/6 is 1 pi. 7/6, 8/6 is the 4/3. 9/6 is the 3/2. 10/6 is the 5/3. 11/6, and then 12/6, which is the 2 pi. So hopefully that makes a lot of sense there, and that's just kind of understanding how the radians work out. All right, now what I want to do is the last thing I kind of want to talk about is making sure that we know how to convert these. Okay, so here's the way to convert. Okay, it's pretty simple. This is using the idea of thinking, okay, I have degrees. What fraction of a circle is that? And then I have to times that fraction by 2 pi. This is the same thing. Okay, it's just reduced, kind of a way to remember to do it. So if you're in degrees, so if you're going from degrees, so if I'm converting from degrees to radians, you simply multiply by pi radians over 180. You could, if you wanted to. Some people like to do 2 pi over 360. That's fine, but I'm just reducing it. 2 in the 360 reduces to 1 over 180, so 1 pi over 180. So if you're in or in degrees and you want to convert to radians, all you got to do is multiply by pi over 180. If you're in degrees and you want to convert, or if you're in radians, excuse me, if you're in radians and you want to convert to degrees, then you multiply by the reciprocal of that, 180 over pi radians. Okay, so those are really important conversion things you might want to write down. So let's kind of practice this, right? Let's practice this. So if I am 30 degrees, here's the idea. I want the degrees to cancel. So the 180 degrees goes on the bottom. The pi radians goes on top. So basically I'm figuring out what fraction of a circle is 30 degrees, and then I'm timesing it by 2 pi. So you might be saying, well, wait a minute, you're not doing that. Yes, I am. Okay, I really am. Because think about this. If I put a 2 on top here, 2 pi radians, that would make the bottom 360 degrees. So I really am doing 30 out of 360 times 2 pi. It's just a shortened way of doing it. So this would be 30 pi over 180, but then you've got to reduce. The 30 over 180 reduces to 1/6. So I get 1/6 pi, or pi 6 radians. So 30 degrees is pi 6 radians. You can do a really big angle, like 1024 degrees, right? All I got to do is times it by pi radians over 180 degrees. Why does the degrees go on the bottom? Because I need the degrees to cancel so I can get into radians. If you don't like this method, again, go back to thinking, what fraction of a circle is that? 1024 divided by 360 times that by 2 pi. This is the same process though. So when I multiply, I get 1024 pi over 180. And then all I got to do is reduce. So 1024 divided by 180 reduces to 2. It's kind of a weird number. Not a nice fraction, but hey, it doesn't always work out that nice. 256 over 45 pi. So you get this weird amount of radians. But notice that this fraction is bigger than 1. This is because I'm much bigger than a full circle, okay? Remember, 2 pi radians is 360 degrees. That's a little bit over 6. So I'm much bigger than that, obviously. I'm bigger than 360. Negative angles, all you're going to do is have a negative radians. That doesn't change anything. Let's do one more here. Let's do 75 degrees. So I'm going to times this by pi radians over 180 degrees. So I get 75 pi over 180, and 75 divided by 180 does reduce to 5/12. So that'd be 5/12 pi radians. Okay, let's practice a couple converting from radians to degrees. So let's say I'm pi over 5 radians. Now I don't have to write RAD. I usually don't, so I'll just leave it like that. And I want to convert this to degrees. So this time I need the pi radians on the bottom so that it cancels. And I need the 180 degrees on top. If you're not comfortable doing the reduced method, which is just smarter to use the reduced method, you could do 180, or I'm sorry, 360 over 2 pi, whatever. But I need the radians in the bottom so they cancel. So I get 180 pi divided by 5 pi. And this is great because look what happens. The pi's cancel, and I just get 180 divided by 5. It's just 36 degrees. So 36 degrees is pi over 5 radians. Let's do another one. Let's do 2/7 pi radians, okay? I want to convert that to degrees, so I need to put the pi radians on the bottom so that the radians cancel. 180 degrees on top. And let's see here, I get 2 times 180 is 360 pi divided by 7 pi, and this is going to be in radians. I'm sorry, my answer is going to be in degrees. The pi's cancel, and I get 360 divided by 7, and this is not working out perfect. It would be 51.43, approximately 51.43 degrees. It didn't work out so nice because 7 doesn't go evenly into 360. You get the idea. Now, watch out because there could be a problem like this. 4 radians. 4 radians. Now, if we go all the way back to our picture over here, Okay, it's way back over here somewhere. There it is. Look where 40 radians is. Here's 1 radian, 2 radian, 3 radian. Here's 4 radians right here. So notice it's bigger than 180. So notice the other thing that's weird about this problem, as I slide all the way back over, is there's no pi. You don't have to have a pi to be radians. It's typical because one full circle is 2 pi radians, but you could talk about a perfect 1 radian. All that means is that the radius and the arc length cancel each other out. That was perfect, right? There was no pi to be, it was kind of canceled out. So the 4 radians could be an amount of radians. So I'm going to have to use the same idea. I have to multiply by 180 over pi radians. So I get 4 times 180 is 720 over pi. Now notice what happened here is the pi doesn't cancel like it did in these other ones. Well, because there wasn't a pi in the original problem. Hey, what are you going to do? So I would just do 720 divided by pi on my calculator, and I get approximately 229.18 degrees. Now, if I go all the way back to that picture I showed you guys all over here, that really should make sense, right? So if I think 1 radian, 2 radians, 3 radians, 4 radians is all the way here. All the way there is 4 radians. That would be 229 degrees. It makes sense that that would be about 229.18 degrees. So hopefully after watching this video, you understand radians. You might not completely understand it until we really dive deeper and deeper into it. But it's this idea that we're measuring angles based on the arc length and the radius. So remember, how do you find radians? You take arc length divided by the radius. Okay, so one more thing I kind of want to do here. One more thing I want to do so you really understand this. If I have a circle, and that's not a very pretty one, I know, I apologize, and I draw in this circle for you here, and I tell you that this circle has a radius of 8, and I tell that the arc length that's created, this long arc length right here, I actually measured it, and it was 72 inches. Okay, so this is 8 inches, that's 72 inches. Now, this might not make sense. I might not have this perfectly drawn on the scale, but what does that tell me? What is this angle? Well, remember, measured in radians, it's arc length, 72, divided by radius, 8. So 72 divided by 8 means that that is 9 radians. Now, I did a poor picture here because 9 radians is clearly bigger than a full circle. So this actually makes, you know why I messed up, because if you think about it, the circumference would be 2 pi times 8, and that's 50 inches if you would actually figure that out, and I'm at 72. So I should probably do a more reasonable example. Didn't really think too much on that one. I apologize. So let's say that this is 8 inches, and my arc length is 13 inches. This might make a little bit more sense. So again, how many degrees? I'm sorry, not degrees. How many radians is this? Well, radians is arc length divided by radius. So it'd be 13 divided by 8, which is 1.625. 1.625. So this is 1.625 radians. Now that picture makes a lot more sense. And if I wanted to convert that to degrees, I would take the 1.625 radians, and to convert to degrees, I need 180 degrees on top, and I need pi radians on the bottom. So I get 1.625 times 180, which is 292.5 divided by pi. So let me do the 292.5 divided by pi on my calculator. I get 93.11 degrees. So this should all come together and make sense. So look at this picture. 13 inches is that arc length. 8 inches is the radius. So 13 divided by 8 is how many radians I am. Convert that radians to degrees, and I get about 93 degrees. That picture actually looks like it might make a little bit of sense. Not drawn perfectly, but a little bit of sense. This one was bad almost because 72 was way too big. That was bigger than the full circumference of the circle. So hopefully the idea makes sense. We're going to do a lot more examples just like these in class to get you guys caught up. So watch the video, take some notes. Hope everything makes sense. Love you guys. Talk to you later.